Modern refrigerators fail often not from major compressor breakdowns, but from a tiny, replaceable $4 part. Yet many repair services quote you $600 or more, claiming compressor failure to push a replacement. This practice drains household budgets and fuels a cycle of unnecessary waste. In your grandparents' era, durable electromechanical parts were standard, and appliances served for decades. Today, I'll uncover the real science behind a PTC Start Relay and show you the safe, methodical process to diagnose and replace it yourself, restoring your refrigerator's life for pocket change. The knowledge is yours to reclaim. They built an empire on your silence. Walk into any appliance aisle today and you're staring at sealed white boxes engineered with a single expiration date in mind. It's not an accident that your grandfather's refrigerator still runs while a 5-year-old unit gets hauled to the curb. Post-war engineering was different. In the 1950s through the 1970s, American and European manufacturers competed on one brutal metric: longevity. Refrigerators used straightforward current-type relays, robust mechanical contacts, and components you could actually see, touch, and service with 2 screwdrivers and a multimeter. Those machines were designed to outlive their owners. Fast forward to now, you get proprietary electronic control boards sealed in epoxy, no schematics in the manual. When the main board fails, the entire unit is deemed obsolete. The math is simple. A recurring $1,400 replacement cycle earns them more than a $12 relay ever could. That is not a conspiracy theory. It is basic corporate arithmetic hiding in plain sight, but the old physics still works. It never stopped working, and that brings us to the forbidden science, the component they don't want you to understand, the PTC Start Relay. PTC stands for positive temperature coefficient. Inside that small ceramic pellet is a thermistor material with a precise Curie temperature. When the compressor is at rest, the relay is stone cold. Its resistance is extremely low, fractions of an ohm. Line current rushes into the start winding, creating a violent phase shift and massive starting torque. That surge heats the PTC pellet in under a second. As the thermal mass hits the Curie point, resistance spikes thousands of times. The start winding is electrically disconnected, leaving only the run winding in circuit. One click, one phase change, pure electromechanical logic from the 1940s. No software, no digital handshake. Just Ohm's law and a lump of doped ceramic doing exactly what it did in a 1955 Frigidaire. That is the sound of a simple electromechanical principle holding the line, proven since 1940s. Now, before you even touch a screwdriver, we establish the non-negotiable framework. This is education. Electricity can kill you without a sound. Always unplug the appliance from the wall. Verify 0 voltage at the compressor terminals with a certified multimeter. Silence that beep, test it on a known live circuit first, then confirm dead. Wear safety glasses and insulated gloves rated for the voltage you expect. If any of this makes your hands shake, close the video, consult a licensed technician. Still with me? Good. Clear the area around the compressor. Remove the terminal cover. Identify the relay and the thermal overload protector. Do not pull wires yet. Do not jump to the swap. You are here to study, to diagnose, to restore, not to gamble. For exact wiring diagrams, torque specifications, and the full diagnostic tree, download the Forbidden Vault blueprint from the description. That document is your millimeter-accurate map when every second counts. You are now looking at an electrical interface that has remained unchanged for over 70 years. No planned obsolescence can touch this. That click you'll hear when the relay opens is the sound of your $600 plus save. Money that stays in your pocket out of a boardroom's quarterly earnings. But what about the hidden diagnostic trick that reveals whether it's truly the relay or a deeper compressor issue? Keep watching, but knowing their playbook isn't enough. You need the physics. The cold, hard, unchangeable physics that those corporate engineers hope you never learn. In the 1950s, a German or American refrigerator was built for the field. The start relay was not buried in a sealed black box. It was a replaceable component, a bolt-on part. That design respects the technician. It respects you. The PTC thermistor at the heart of this relay has not changed. A simple ceramic disc. It behaves the same way it did 70 years ago. What changed? The packaging. They made it non-serviceable. They erased the pinout from the manual. They turned a $10 part into a $1,000 sealed compressor assembly. Engineered obsolescence. Pure and simple. Now, the forbidden science. Your compressor is a single-phase induction motor. It has no inherent starting torque. It needs a phase-shifted magnetic field to begin rotating. That is the job of the start winding. But that winding can only handle a brief pulse. If it stays engaged, it burns out in seconds. Enter the PTC relay. When cold, it presents a low impedance path. Current rushes into the start winding. The phase shift happens, the rotor begins to spin. Within milliseconds, the ceramic disc self-heats. Its resistance skyrockets toward infinity. The start winding disconnects. No arcing contacts, no mechanical clapper. Just a silent solid-state transition. Beside it, the overload protector sits. A bimetal disc responds instantly to excessive current or heat. It warps, opens the circuit, then snaps back when it cools. Both components must function as a matched pair. If one fails, the other is forced to compensate until it too fails. Your forbidden vault schematic details the procedure precisely. Follow it. Grab your multimeter, dial in resistance, find the common terminal, measure run winding to common, measure start winding to common. You hear the crisp beep of continuity. You note the exact ohms. If the value is open, that winding is dead. Now test the PTC relay cold. It should read near 0 ohms. Warm it in your palm or with a gentle heat source. Watch the resistance climb to infinity. If it stays shorted, you have found the silent killer. If it stays open, the same. Check the overload protector at room temperature. It must show continuity. No beep. It has tripped into oblivion, failing safe but failing permanently. That 30-second resistance check just saved you $700 in unnecessary labor and a compressor you did not need. All the exact ohm values, the pinout, the terminal identification are clearly shown in the Forbidden Vault document. Link below, print it, laminate it. This schematic is the difference between a 10-minute diagnosis and a $1,000 surrender. However, a common installation mistake can instantly destroy your new relay. So in the next chapter, we reveal the precise mounting posture that guarantees success. But knowing their playbook isn't enough. You need the physics. The forgotten rules buried under 40 years of quarterly earnings reports. 30 years ago, swapping a start relay was like changing a spark plug. Every homeowner kept a spare in the junk drawer, right next to the fuses. Then the suits realized they could sell whole sealed systems instead of a $5 ceramic disc. They erased that chapter from the collective memory, told you the compressor was dead, not diagnosed, sold. That black plastic box on the side of the compressor houses a PTC thermistor. No moving parts, no magic, just a chunk of barium titanate that gets hot and chokes current. It pulls a heavy pulse through the start winding for a split second, then drops the amperage to 0 as it heats up. Basic Ohm's law: cold, low resistance, hot, high resistance. That's the entire ignition sequence for your cooling unit. But the thermal mass and resistance curve must match the winding characteristics exactly. Use a universal relay without cross-referencing the vault specs and you gamble with a $100 motor. The correct part number is not a suggestion, it's physics. Now we execute. First, safety: unplug the unit. Discharge the run capacitor across its terminals. Treat it like a loaded weapon. Double check with your multimeter, 0 volts, no guesses. Remove the overload protector. Look at it before you pull it. It may be directional. Flip it the wrong way and you lose your thermal protection. You'll cook the windings blind before the breaker trips. Photograph the old wiring before you touch the spade connectors. One crossed lead and that $4 relay becomes a $20 mistake. The exact color-coded diagram waits in the vault. Use it. Unplug the old PTC relay, wipe the terminals if they're corroded. Press the new relay's spade connectors on by hand. Feel for that solid brass click. Never hammer. Never pry. Forcing distorts the female terminal and creates a hot spot. A hot spot means a fire risk 6 months from now. Reattach the overload protector in its original orientation. Secure the terminal cover. Now you power up. Plug it in. Listen, that rising hum, the subtle click as the relay opens the start winding, that's the sound of $1,000 staying in your account. If you own a clamp meter, clamp the run wire. Ideal draw at room temp is 1 to 3 amps. Anything above 4, cut power and recheck the capacitor. But before you close the cabinet, there's one final diagnostic that confirms this repair will outlast the factory warranty. Skip it and you'll never see the hidden crack slowly bleeding refrigerant. That test is next. That knowledge you just acquired wasn't hidden because it was dangerous. It was hidden because it was profitable to keep you helpless. Back when a handshake meant more than a warranty card, every homeowner knew the relay click. They knew the coil needed brushing twice a year. They knew the gasket should hold a dollar bill tight. This was common inheritance, passed down, not sold. The suits erased it, not with guns, with sealed units and missing schematics. They took a $4 fix and buried it under a $1,000 replacement lie. Your grandfather's confidence didn't die of old age, it was systematically starved, but erasure isn't extinction. So let's talk about what actually lives inside that little black box you just replaced. The PTC relay, no microchip, no logic board waiting for a firmware update that will never come, just a disk of barium titanate. When current flows, it heats. When it heats, its resistance spikes. When resistance spikes, the circuit opens. When it cools, it resets. Pure physics. A thermal feedback loop governed by Ohm's law and the immutable properties of ceramic. No software engineer can schedule its obsolescence. No boardroom can push a kill switch to a dumb piece of rock. That relay doesn't know what year it is. It doesn't care about quarterly earnings. It just works for decades. Because basic physics doesn't expire. Now the solder has cooled, the panel is back on, but a true restoration demands 3 more breaths of your time. First, the condenser coils, there at the back or underneath, probably wearing a gray blanket of neglect. Unplug the unit, take a soft brush, a vacuum with a crevice tool, and gently clean those fins. Not hard, you're not scraping paint. You're restoring a thermal exchange surface that your energy bill depends on. Every degree of trapped heat that can't escape costs you real money. This takes 90 seconds. It just saved you $200 a year in wasted electricity. Second, the door gasket. Close the door on a dollar bill. Pull it out. If it slides free without resistance, cold air has been leaking since the day that seal lost its memory. You weren't just cooling your food. You were air conditioning your kitchen floor. A new gasket costs $12. The vault blueprint shows you the exact part number and seating technique. Third, breathing room. Pull the unit 2 inches from the wall. Let the heat leave. An appliance choked against drywall runs its compressor to death. It's not designed to fight for air. It's designed to run cool and steady. These 3 steps, combined with the relay you just installed, don't just repair a refrigerator. They restore its original efficiency curve. The curve the engineers drew before the cost cutters got involved. The Forbidden Vault contains that original curve, every schematic, every parts list, every torque specification and maintenance interval your unit was born with. It's not a hack. It's the engineering documentation you were supposed to have. The millimeter-precise blueprint, so you never second-guess a terminal connection again. And I will say this with absolute clarity. If after the repair you hear unusual noise, feel excessive heat, or trip that overload more than once, disconnect power immediately. Put your hands in your pockets and call a qualified technician. Self-reliance is knowing your limits as clearly as your capabilities. Pride doesn't cool your food. Wisdom does. Legacy engineering. Alive again. Zero electronics. Pure physics. That's the sound of permanent independence clicking into place. And now, Dr. Silas leaves you with the philosophy that turns a simple repair into permanent independence. Knowledge and sound engineering are your best defense against designed obsolescence. The $4 relay proves that simple, proven science still triumphs. Subscribe for more practical appliance repair solutions to stay independent.